Okay, in this lecture we're going to look at specifically how to deal with copy constructors and when we need to create copy constructors. The idea behind a copy constructor is that sometimes we have classes that cannot use just simply the default copy constructor or the default equal assignment operator because inside that class there may be dynamically allocated data. When we make copies of dynamically allocated data, if we use the simple shallow copy, then what we end up with is two objects that point to the same area in memory. And what we'd really like to have is a copy that has its own version of whatever's in the dynamically allocated memory area. So we need to allocate a second space and make the new pointer of the copy point to that new space so that we don't have two objects that can potentially change the same data. That's the essence for why we need to worry about this. So we know that a default constructor is automatically created for every class when we instantiate it. And we know that there's a destructor. But there's also a default copy constructor and a default assignment operator overload created when we create an instance of a class, or the first time we instantiate a class, so that these operations can happen seamlessly. We've already covered the constructor and the destructor, but we haven't talked about the copy constructor and the assignment equal overload operator. The copy constructor is a special kind of constructor that's used whenever we need to create a copy of an object. And typically this happens implicitly whenever we have the object defined to have the value of another object across the equal sign, if you will, or when it's passed by value into a function, not by address or reference, or when it's returned by value from a function, because we have to create a copy of what was there before. So these things typically happen automatically, and for most of the classes that we've created so far, that hasn't been a problem. But if we have things like pointers and dynamically allocated memory, then we have to have a special constructor for that and a special assignment operator. So here's some examples of when the copy constructor or the assignment equal operator might be used. For example, in the second line of code here, we're creating a new fraction object, f3, but we're assigning it to be have the same contents as the previously created f2 above in the declaration. So this would invoke the copy constructor to make that happen. And as long as this fraction class does not have any dynamically allocated data, this will work just fine. Transparently, we don't have anything to worry about. In the last line of code shown here where it says f1 equal f2, that's actually not a copy but an assignment operator. So it's going to use the default assignment operator, which again, as long as there's no dynamically allocated data, will work just fine. If we need to create a copy constructor because we have dynamically allocated data, then the way we do that is we create a constructor that has one parameter, and that is a reference or the address of the original object. It has to be the same type as the object being copied, and it always is passed by reference. Because if we pass by value, that would invoke the copy constructor, and we'd end up with a circular definition. So, but in many cases, the copy constructor is not required. So here's an example of creating a copy constructor for the fraction class that we just used in the previous example, and also one perhaps for a time class. And notice the use of the word const, because the reference that we want to pass, we don't want it to be modified. So this creates this notion of something called a shallow copy versus a deep copy. The default copy constructor, and for that matter, the default assignment equal operator, both work fine as long as we're making what we call a shallow copy. In other words, all the entities, all the attributes in a particular class are all finite values. They're not pointers to complex data. They're not dynamically allocated. That way we can make an exact copy and it's not a problem. A shallow copy then will be sufficient for passing as a parameter, copying across the equal sign, etc. But when we have a pointer to dynamic data, that shallow copy is not sufficient because all it's going to do is copy the pointer value or the address, and then both objects are pointing to the same data for that particular attribute or set of attributes. So in this case, we need what's called a deep copy, where we're going to allocate additional memory for the new copied version of the object, and then copy the actual data from the dynamic area into the new area, so that each have their exact copies of the information, but they have their own copies. They don't both point to the same copy. And then we end up with one object being able to change the data for another object. So in this example, for some class called directory, here we've defined a copy constructor. And what this does is it copies over all the data. Some of the data obviously is static, but that's okay. It's not static, but it's simple values like the max size. So copying over the value of max size from the copy that we're making. So where D in this case is the original, and then of course we use the internal variable names for the new copy. So we copy over max size and current size. Then we create a new array of size max size and copy over all the values up to current size from the previous list into the new list. So obviously this particular class has a dynamically allocated array that perhaps grows as necessary, much like what we've done in the previous exercises in the early part of the class where we used arrays and not standard template library collections. And we had one that grew based on some chunk size. Well, this is copying it over, creating one of the same size, and then copying over all the elements that are currently being used up to current size. So this would be an example of a deep copy, creating space, copying over all the elements so that each of the two entities of type directory, in this case, have the exact same contents once the copy is completed, but in the event that we change data, each one can change its own data independent of the other. Now, for an operator equal overload, although that's not in this slide deck, we would do basically the same thing. We'd have an operator equal overload method. In fact, it would probably have the exact same code in it. In most cases, the copy constructor and the operator equal overload do the exact same thing. So we could take this exact same code and create an operator equal overload for the directory class, and it would have the exact same parameter and would have the exact same code. The only difference would be basically the prototype of what that function looked like. So usually once you write one, writing the other one is a trivial matter. So in this case, what we could do, for example, let me just create a new slide, and what we'll do is we'll just make a copy of this code. And if we went to this new slide, what we would do if we wanted to add text, I would say directory operator equal, spell right, operator equal, and then the argument would be a directory const directory reference. And let me just make this a little bit smaller text so it all fits easily. And so there we have it. We have the definition of the operator equal overload, and then the exact same code that we would have created otherwise. Hopefully during the lecture time, if you have any questions, you can ask about the need for copy constructor and how we go about creating one, as well as the operator equal overload.